Hi everyone, this is going to be a short video. I've chosen two problems from the 8.4 study guide to just review with you. We've already done this in class, but in case anybody wants to go back and review this, they can. Okay, so the two problems that I've chosen is number 3 on the front side and number 6 on the back side. So on number 3, we have a diagram here. We know all three of the sides. So we're not going to be using the calculator to find these ratios. We know the sides, so we're just going to find what the ratios are. I've seen some confusion in class with that. But anyway, the directions say find the sine of j, cosine of j, tangent of j, and sine, cosine, and tangent of the other acute angle L. So first thing we always do is Sohcahtoa until we are really proficient at this. We just keep writing this down. Alright, so let's start with the sine of j. The sine of an angle is the ratio of the opposite side to that angle divided by the hypotenuse. So the sine of j, if you look from j's perspective, the opposite is 36. And the hypotenuse is always going to be opposite the right angle. So 24 square roots of 3. Now we don't like to have an irrational number in the denominator, so it's called rationalizing the denominator. So we're going to get rid of that square root of 3 by multiplying it by itself. And if we do that on the denominator, we have to do that in the numerator, because essentially we're multiplying by the number 1. And what we get is 36 square roots of 3 on the top. And we have 24 times square root of 3 squared, which is 3. And we can just simplify this. We've got 36 divided by 3 is 12. So we can simplify this to 12 square roots of 3 divided by 24. And we can further simplify that to 1/2. So the sine of j, rationalized, is square root of 3 divided by 2. Now I'm going to look at the cosine of L, and I hope you see the pattern here. We talked about this in class. Cosine of the other acute angle is going to be the adjacent divided by hypotenuse. And from L's perspective, the adjacent here is also 36, and of course the hypotenuse doesn't change. So we've got the same thing, 36 divided by 24 square roots of, 3. And you can see the relationship here. We can go all the way over here. They are equal. So the sine of one acute angle is equivalent to the cosine of the other acute angle. So now let's take a look at the cosine of j. Cosine of j is adjacent over the hypotenuse. And from the perspective of j, the adjacent here is 12 square roots of 3, and that's being divided by the hypotenuse, 24 square roots of 3, and they cancel, and 12 divided by 24 is going to give us 1/2. And the cosine of one angle, one acute angle, is equal to the sine of the other acute angle. So if I look at sine of L, sine is opposite over hypotenuse, and the opposite of L is 12 square roots of 3. So we have exactly the same thing here. Hopefully you see that. And they are going to be equal. So we've got these as a pair that are equal, and these two as a pair that are equal. And finally, looking at the tangent of an angle, so I'll start with j, equals the opposite divided by the adjacent. And from j's perspective, the opposite is 36. Divided by the adjacent, from j's perspective, the adjacent is 12 square roots of 3. And we've got to rationalize that denominator, so I'm going to multiply the top and the bottom by square root of 3, and I get 36 square roots of 3 in the numerator, and I have 12 times 3 here in the denominator. So you can see that Tangent of j simplifies to the square root of 3, as these will reduce out to 1. And finally, the tangent of the other acute angle, L, is going to be the opposite over the adjacent. And the opposite for angle L is 12 square roots of 3. And the adjacent for angle L is 36. And we can simplify that to square root of 3 over 3. And it may not be obvious, but these are reciprocals of each other. If I put 1 over the square root of 3 and then rationalize that number, I would end up with exactly square root of 3 over 3. Okay, number 6 on the back side of the worksheet. Now we're going to use the calculator to find the measure of angle T to the nearest tenth. Always Sohcahtoa. Now when we are trying to find the side lengths, if we're trying to find any missing side lengths, we're going to use the sine, cosine, and tangent functions. If we want to find the angle measures, we're going to use the inverse functions. So from the perspective of angle T, we know the opposite. So that's in sine and tangent. And from the perspective of T, we know the hypotenuse. So that's here. So hopefully you can see on this example, we're going to be looking at the inverse sine function. So let's go ahead and write that. The inverse, again, that -1 looks like an exponent, but it's really just a notation style. The inverse of the opposite over the hypotenuse, that ratio, is going to equal the angle measure. So the inverse of the opposite, 14 square roots of 2, divided by 39, is going to give us that angle T in degrees. And at this point, we do need to use the calculator. Remember that 14 square roots of 2, 14 is multiplying the square root of 2. So you're going to go ahead and do that. We're going to take the square root of 2, and we're going to multiply that by 14 and divide that by 39. And at that point, we're going to take the inverse sine. And I get 30.5 degrees for angle T. Remember important things here. Depending on your calculator, you may need to enter the numbers first and then press the inverse sine button. That would be the case with the iPhone products. But the TI calculators that we use in class, you'll actually find this, you'll actually hit the inverse sine button first and then plug this into parentheses to get that angle. And always remember that your calculator needs to be set on degrees. Thanks for listening. Hope this helps.